Welcome to the YouTube channel of Unique World Education. Today we are going to discuss about the grade 10 electricity chapter. So in this video we will be covering the important topics from the chapter, and at the end we will be discussing some questions from the previous year board exam, CBSE grade 10 board exam. So let's start the chapter. So we'll be discussing the most important thing from the chapter. So anyhow, the chapter starting with what? Electric current. So chapter starting with the concept of electric current. So you should understand what is an electric current. Before that, you should understand what is the meaning of charge. So basic things only you need to understand this chapter. Charge, we have two types of charge. One is positive charge, one is negative charge. Here, the charge flowing in a given time, we can call it as an electric current. So first in this chapter you need to be in mind what is a current is equal to charge flowing per time. And what is the unit of charge? It is coulomb. And what is the unit of time? It is second. But what is the unit of time we are taking? It is ampere. So don't confuse about the units. Then we have to study the next equation. Q is equal to N into E. What is N? N means, I told you, current is the flow of charge carriers. Now N means what is the number of electrons flowing in the second. So here it is a charge flowing in the second. 1 coulomb of charge means there is a number of electron multiplied with charge of an electron. So N we can write it as number of electron. Okay, I am using some shortcuts. And E means it is a charge of an electron. I hope you know the charge of an electron. So send me the answer in the chat box. What is the charge of electron? Everyone know that one, right? So write the charge of an electron at the chat box. So let me see. Then, so these are the very important things. I is equal to Q by T. Note down these two equations. Then Q is equal to N into E. Then let's move on. Then the very important thing again after coming in this chapter is like, okay, 1 second. What is Ohm's law? The beautiful Ohm's law we have to discuss now. What is Ohm's law? When there is a conductor, if there is a current carrying conductor, let it be any metal. If I am connecting this conductor to a battery, for example, this is the battery. Definitely the battery is giving some potential difference. For example, I am taking a 5 voltage battery. The battery is able to create a potential difference of 5 and potential difference of 0, means the difference in potential he can create is 5 between the two ends of the conductor. So the battery is creating 0 potential at one end, 5 potential at the other end. So what is the difference here? 5. So Ohm says that this potential difference is proportional to the current flowing through the conductor. So it is like just taking a current carrying conductor. You can just consider this is a test tube. This is a tube full of water. So I am just increasing the potential. So the two ends is getting the same potential, but the water will not flow out. But if I am making a potential difference like this, definitely water will flow out. Same as like Ohm says that what is the difference in potential you are creating, that much of current will be flowing through the conductor. But here this is the ideal case. One more factor which is controlling all this thing is called V is equal to, I am multiplying with a proportionality constant R, and we are getting V is equal to IR. This equation is based on the Ohm's law. And what is Ohm's law? Definitely we will get a question to ask, define Ohm's law. What is Ohm's law? Ohm's law says that in a conductor, the potential difference across the two ends of the conductor is directly proportional to the current flowing through the conductor, provided that the temperature should be constant. Temperature should be constant. So please tell with me, temperature should be constant. Once again, tell it with me, say it again, repeat it with me. The Ohm's law says that in a conductor, the total voltage, so the potential difference across the two ends of the conductor is directly proportional to the current if the temperature, provided the temperature should be constant. So this is very important concept, and you have to write the equation of resistor also. Resistor is equal to V by I, and this constant we are calling it as resistance. This constant we are calling it as resistance here, because the voltage will be equal to current This is the what Ohm's law says that. But if resistance equal to 1, clear? If resistance equal to 0.5 or 1 by 2, then voltage will be equal to I by 2. So they are not equal in this time. So these are always proportional, and who is controlling all these things? The resistance. So we can define the resistance right now. It is the property of a material to oppose the flow of current through the material. That is called the resistance of a conductor. What is a resistance? It is the property of a material to oppose the flow of current through a conductor. And let's see the units of all these things. Current we already discussed, ampere. Voltage nothing, it is volt. And resistance it is ohm. Why? Because Ohm's law. Clear? So we can write this unit of resistance are ohm. So this is the second topic in the chapter. What is Ohm's law? What is the equation? How to get the equation of resistance, and what is resistance? Clear, everyone? So now let's try to write an equation here. One second. Okay. So you can take a screenshot right now. So we got the equation as R is equal to V by I, or I is equal to V by R. So we can define a current I is equal to 1 ampere. It is the current when voltage is equal to 1 volt and resistance is equal to 1 ohm. So how we can define a 1 ampere current? It is the current that is flowing through a conductor of resistance 1 ohm when it is applied a voltage of 1 volt. Just be in mind, these are the basic important thing in the Ohm's law. So second topic we finish. First topic, I is equal to Q by T, Q is equal to N into E. Second topic, what is Ohm's law? Equations related to Ohm's law. Now let's move on to the third topic in the chapter, the factors affecting resistance. Factors affecting resistance. Okay, so factors affecting resistance. So the resistance who is controlling the current in a circuit, right? So we need to know what all factors are this resistance is depending on. So definitely we have a relation like resistance is directly proportional to the length of the conductor. If you take a length of 1 meter, it will have a resistance, but if you take a length or wire of length 2 meter, it will have more resistance. And resistance is inversely proportional to the area of cross section. So if I am taking a cylindrical conductor, if I am cutting here, I will get a circle, right? So it depends on the area of cross section, but it is inversely proportional. So we can write these two equations together. R proportional to L by A. So to remove this proportionality constant, we can just substitute R is equal to rho into L by A. Most of the students are getting confused on this. What is rho? What is rho, sir? Everyone is asking what is rho. So rho is the resistivity. What is called? Rho is the resistivity of the conductor. Rho is called resistivity of a conductor. Now what is resistivity? So other than this length and area, resistance also depending on a very important factor, resistivity. It is fixed value for a material. If I am taking a steel, it will have a resistivity which is already fixed by the manufacturer. A value of resistivity which is already fixed by the manufacturer. If I am taking iron, it is also having a resistivity values, and the values of the resistivity it is given in the textbook itself. You can just refer the table. And if I am taking whatever material, the resistivity it is fixed. So from this equation we can write the resistivity as R into A by L, and we can just find the unit of the resistivity. We know the unit of resistance is ohms, unit of length is meter, and unit of area is meter square. So how to find the unit of resistivity? It is a normally asking question. Ohm into meter square by meter cut meter, 1 meter, you will get the answer as ohm meter. So what is the unit of resistivity? It is ohm meter. Unit of resistivity, it is ohm meter. This is very important thing. Factors affecting resistance: length, area and resistivity. And what is resistivity? Try to understand the different values of resistivity of all the material. Then we are moving on to next important topic, that is resistance combination. So now before that, let me tell you some other things. We know that resistance is equal to V by I, R is equal to V by I, unit is ohm, resistivity is ohm meter, these all things we know, and equation of resistance is rho into L by A. So we can create a material same like a symbol like this component is called a resistor. Okay, this resistor has lot of practical application. For example, I am connecting my mobile into a battery. So this is just an example only. I am connecting my mobile into a battery. So my mobile, I am expecting that too much current never pass through my mobile. So I need a person to control the flow of current. So I will take the resistor which is having a particular value. So the resistor is a device which is having resistance. So resistance is the value or ability, the amount of capacity, how much it can block the current. A resistor means it's the device. So I'm taking a resistor of 5 ohm means it is the value of resistance. Clear? So here we can take different types of resistors and all. And how to resistor and what is the difference between resistance and resistor? For example, I am taking a steel. Just assume steel, the resistivity value is 1.2. It's not the actual value. And I am taking a steel like this. Okay, I will change the color. Okay. So this is a steel bar of length 1 meter, area 2 meter square, and this is steel. So what will be the resistance of this small piece? We can find it. Resistance equal to resistivity of the steel into length you have taken by area you have taken. Resistivity is 1.2, length I have taken is 1 meter, area I have taken is 2. You will get the answer as resistance in ohm. So resistance depends on these three factors. If you take a material having high resistivity, definitely it will have a higher resistance also. This is how these all things are working, and this is how you need to explain in the questions, and this is how you can do the numericals. Clear? Let's move on to the next topic, combination of resistors. For example, I am going to create a circuit. I just want, because I am just going to a shop, I want to make a 9 ohm resistance, but the shop only have 3 ohm resistance. So how can I make 9 ohm from 3 ohm? And I want to, for example, I want to make a 1 ohm also, and the shopkeeper only have the 3 ohm. So how to make this 3 into 1 and 3 into 9? So that's the relevance of combination of resistance. We have two types of combination of resistance you need to study. One is series combination, the other one is parallel combination. You know the basics. If you are connecting a resistance like this is called a series, and if you are connecting a resistance like this is called parallel. Series means if I am connecting a voltage to a resistors which is R1 and R2 which is connected in series, definitely there is a current will be flowing through the circuit. For example, I am connecting into a battery, plus minus. So the bigger line is plus, the lower is minus. So current will be flowing from positive to negative. Current always will be flowing from higher potential to lower potential. Current is coming here. I will take the different color for current. Current is coming here and here. Here there is no other way for the current to pass through it. So only one current, the same current passing through R1 and R2. So here we can see in series connection, current will be same. So write the first point, current will be same for series connection. But you see this one, voltage across the first resistance will be I into R1, voltage across the second resistance will be I into R2. But voltage is not equal, voltage depends on the resistance value. If I am taking high resistance value, the voltage is depending on that much of resistance. But in parallel case, okay, I am connecting the parallel circuit. For example, this is R1, this is R2, a current definitely will be flowing through this circuit. So this is the current flowing, but here when the current comes here, he has two paths. So this is the first way and this is the second way. So the two resistance R1 and R2 is not getting the same current. So directly we can write current in a parallel circuit will be different. And here we can say that resistance R1, one end is directly connected to the positive, R1 other end is also directly getting the negative polarity. So R2 also getting the same polarity. See, R2 one end is connected to the positive, so he is also getting the same potential difference of the battery. So we can say that voltage will be same. Voltage is same, current will be different in the case of a parallel circuits. I hope this point is clear. Now let's see what is the effective resistance in a series connection. It is nothing, just add the two resistors R1 plus R2. But what is the effective resistance in parallel circuit? You have to write this equation. 1 by R effective is equal to 1 by R1 plus 1 by R2 plus 1 by R3. It is going like that. And also you can write the another equation as R effective is equal to R1 R2 by R1 plus R2. These are the two equations you can use to do these things, do the numericals from the chapter. I hope the point is clear. So combination of resistors we discussed, study the properties of series and study the properties of parallel, then the effective resistance. Clear? Okay, any doubt in this you can post in the chat box. I will reply in the chat box itself. Okay. Now you can take the screenshot. Let's moving on. I have a 3 ohm resistors. This is a board exam question like this. They are asking. I have 3 ohm resistors. 3. I want to make a 9 ohm resistor. Very simple. Just connect in series. Clear? 3 plus 3 plus 3. 6 plus 3. 9 ohm. But I want to make a 1 ohm resistor. How? Connect these 3 resistors in parallel. You see this one? 1, 2 and 3. So this is 3 ohm, this is 3 ohm, this is also 3 ohm. Okay, now let's see how we can do the finalize or how we can find the effective resistance is 1 by R effective is equal to 1 by R1 plus 1 by R2 plus 1 by R3. What is this? Since the denominator is same, we can add the numerator. 1 plus 1 plus 1, it is 3 by 3 is equal to 1 ohm. So in parallel connection we are getting, not the very important point, minimum resistance means resistance value decreases. But in series connection, resistance value become 9 ohm means the resistance value increases. So here we can write in series connection means maximum resistance and in parallel connection means minimum resistance. I hope this point is also clear. Let's move on to the next and last topic of this chapter. Very simple chapter, right? Okay. The last topic of this chapter is nothing. What is the power generated in a circuit or power delivered into a circuit? If there is a resistor I have connected and I just applied a battery here, the battery will produce a potential difference across the resistor. Because of the potential difference, a current will be passing through the resistor, and here we can directly write the power generated across the resistor is equal to what is the voltage you applied, what is the resistance. Clear? And also you can write like V is equal to IR into I. You will get the answer I square R. Again you can create another equation, V into what is I? V by R. This is equal to V square by R. Now I am giving you a trick, like for series connected circuits use this equation. For parallel connected circuit, use this equation. You can just check with the resistance values and all. You can just check with the what is the resistance, where the other one resistors in the denominator, the other one resistors is directly proportional. So this is the equation of power. Then the last and next topic is what is the heat generated. What is the heat heat generated. Definitely, when we are giving a power to a circuit, a energy will be released. That power will be converted to the energy. So battery is giving a power V into I. That power is converted to heat in the case of a resistor. Means when I am connecting a voltage to a resistor V, this is the R, definitely a current will be passing through the resistor and a heat will be generated. So heat generated is equal to, it depends on what is the power you are giving and how much time you are using. For example, I have a iron box. The power of the iron box is given in the box, and it depends on how much heat it is or how much energy it is taking. It depends on how much time you are using the iron box. This is how it works. We can write H is equal to P into T. P is equal to VI into T, one equation. H is equal to I square R into T, second equation. H is equal to V square by R into T, third equation. This is how you can take the equations of heat generated. Clear? So this energy is the one we are calculating to find the current bill. We normally used to say current bill 1, current bill has come, current bill has come. So it is actually like we are how much energy we have used. They are calculating actually how much energy we are using. And here the unit of power is equal to watt. Watts are same as like. So unit of power is watt and unit of heat is joule. Unit of energy is joule. Unit of power is watt, unit of energy is joule. For high power devices, we use the power unit as kilowatt. Okay, we use the unit of power as kilowatt in high power devices. So 1 kilowatt is equal to 1000 watt. So energy is equal to power into time. So energy, if you are using a high power device, the energy delivered in or energy that is used by the device is equal to power. We can write the unit as kilowatt, and time normally we are using second, but for high power devices we are using in hour. So we need to know what is 1 kilowatt hour is equal to, just listen, 1 kilowatt means 1000 watt. 1 hour means 60 minutes, 60 seconds. So 60 into 60, we will get 3600 into 1000 means 336 into 10 raised to 5, or else 3.6 into 10 raised to 6. Clear? So 3.6 into 10 raised to 6. 3.6 into 10 raised to 6 joule. So this can be asked in the question, what is 1 kilowatt hour in joule is equal to, you can just convert 3.6 into 10 raised to 6 joule. So these are the important things in this chapter. What is Ohm's law? What are the equations of Ohm's law? Then one important thing I forgot to mention here. So take all these things. Then there is a graph thing is coming from this one. So just listen here. If I am drawing a voltage current graph of a material, so I have a material here, it is a conductor, I applied a voltage across the material, a current is flowing through the material, this is the voltage I applied, and I am just finding the resistance value is equal to V by I. So if I am just noting down the resistance value of the material, I am getting a graph like this, because voltage and current are directly proportional, and the slope of this graph will give slope of the graph, the VI. V should be in the y-axis, I should be in the x-axis. VI graph, slope of VI graph will give you resistance. Slope of VI graph will give you resistance. The point is clear, everyone, right? Now let's see, the slope means how much it is inclined. So if this is the conductor 1, and if the questions are coming like this, if this is the conductor 2, which is having more slope, the conductor 2 having more slope, so that will have more resistance. So question, there is board exam questions are like, they will give you two conductors 1 and 2, they will ask you to find which one have more resistance. In this case, the second conductor will have more resistance because it is having more slope. But in grade 10 CBSE 2024 exam, they gave like current in the y-axis, voltage in the x-axis. So in this case it is just reverse, means this is first conductor and this is second conductor. So here which is having less slope will have more resistance. So resistance of 2 will be greater than resistance of 1, because you have to take care on, don't give the answer directly, just check what is in the y-axis, what is in the x-axis. Though these are the important thing in this chapter. Before going to the numerical, one more thing let me ask you, let me tell you, if I am connecting two resistors into a battery of voltage V, this is R1, this is R2, so the total voltage will be equal to voltage across V1 plus voltage across V2. And what is voltage across V1? Current into R1. What is voltage across V2? Current into R2. And in some question they will ask you to find the power delivered only on R2. So at that time power is equal to I square into R2. Clear, don't confuse, power is equal to I square into R2. So I you can find using the general equation. So let's move on to the questions. Ready? So these are the topics. Take the screenshot for the whatever you want the note. Then let's see, this is a question asked in 2024 board exam. Let's try to solve this question. Okay. Show how would you connect the 3 resistors each of 6 ohm so that the combination has a resistance of 9 ohm. So we have 3 resistors, 1, 2, 3. I just connected in series, don't worry. We have 3 resistors. Okay, I will cut it. 1 second, small eraser. So we have 3 different resistors, each of resistance 6, 6, 6. I need to get a combination value of 9 ohm at the end. How we can answer, or how we can connect these 3 things to get the 9 ohm? Justify your answer. First of all, 9 ohm is greater than the given value 6 ohm, so we can connect in series. But if you are connecting these 3 in series, the answer will be 6 into 3, 18. We don't want that answer. So again, series should be there, parallel should be there. So 18 is the answer, but we need a 9 ohm, so parallel also should be there. So think like this. So it is a question which is having both series and parallel connection. Here we can draw like this. So this is the answer. First I will connect a 6 ohm, then I will connect the 6 to 6 ohm in parallel. Clear everyone? So this is 6 and this is 6. Now let's try to solve the answer for this question. Let's see here. This 6 and 6 are connected in parallel. So what is the effective resistance is equal to 1 by 6 plus 1 by 6 is equal to 2 by 6 is equal to 1 by 3. So this 1 by 3 is 1 by R effective. So what is the effective resistance? It is 3 ohm. Clear. So from the parallel connection we got 3 ohm. Then a 6 ohm is connected in series. So the question we can redraw like, first is 6 ohm, then a 3 ohm. So what is the answer here? We are getting the total effective resistance is equal to 6 plus 3 is equal to 9 ohm. Clear everyone? So this is how we can connect the resistors in combination, given combination. So I'm going to clear the screen. You can take the screenshot. Next question. In the given circuit, calculate the power consumed in watts in the resistor of 2 ohm. So voltage is given. So we need the current. So power consumed in the 2 ohm. We can first find the total resistance. 1 plus 2 ohm is equal to 3 ohm. And we can find the current is equal to V by R. V is equal to 6 by 3 is equal to 2 ohm. 2 ampere. I hope that point is clear. Current is equal to 2 ampere. No doubt, right? So we got the current, we got the resistance, we already found the resistance, we got the current. But here we need to find the power consumed in the resistance of 2 ohm only. I told you, if they are asking specifically, if you are asking to find the power in specific any resistance, P is equal to I square R, and I it is 2 square into what is the resistance, which resistor we need to find the power? 2 ohm. So it become 4 into 2 is equal to 80 watts is the answer. So we answered the two questions. This is how we can find the answer for this question. I hope this point is clear. Yeah. This is the question I told you. Study the IV graph of three resistors of R1, R2 and R3. Select the correct statement. So here you see y-axis is current and x-axis is voltage. But here I told you if it is like this, the resistor, the component, the conductor which is having less inclination will have more resistance. So we can just write the answer as R3 will have more resistance than R2 than R1. So this is how we can answer that question. Okay, so we will discuss more questions on the next class, but in the next video we will be discussing more numerical from the same chapter. So this is a homework question I am giving you. Use Ohm's law to determine the potential difference across 3 ohm. We need to find the potential difference across 3 ohm resistor in the circuit shown in the diagram when the key is closed. So first you need to find the current. Okay. And what is the potential across the 3 ohm? V is equal to I into R, I into 3 ohm. Then I won't tell anything. So do this as a homework and find the answer and send the answer in the comment box, everyone. So we'll discuss more questions on the coming videos. Alright, so I hope everything is clear. Just watch the videos 1 or 2 times. Try to solve the questions, or again take the screenshot. Then do this question as an assignment and submit the answers in the chat box. Okay, thank you all. Thank you. Bye.